In this video, we will learn about how to find the probability density function of continuous random variable. So basically, a continuous random variable is specified by its probability density function, and that function is defined over the range from negative infinity up to positive infinity. So in order to prove that this is actually probability density function, so if we integrate all of the function from the range of negative infinity up to positive infinity, it must be equal to 1. So that's how we prove probability density function. So maksudnya kat sini kalau soalan tu suruh kita buktikan this is actually probability density function. Kita kena integrate semua function yang ada in the range of negative infinity up to positive infinity and our final answer must be 1. So kalau dapat 1, it's proof. Kalau tak dapat, maksudnya dia bukan. Okay. So, when it comes to probability density function, basically we find the area under the function. So, kat sini maksudnya kita nak cakap probability is the same as the area. So, in order to find the probability, every time we have to integrate the function. Okay, kita buat notation sikit lah. Note kat sini, maksudnya apa yang saya cakap tadi. In order to find probability for continuous random variable, we have to integrate. Tak ada cara lain. Setiap kali mesti integrate because probability is the same as the area. Okay. So, since it's involving area, notation of equal sign doesn't matter here. Maksudnya kat sini kalau dia ada equal sign ataupun tak ada equal sign, kita still cari pada region yang sama. Itu yang dia masukkan kat dalam situ. Itu dari segi notation of A and B lah. Saya pakai contoh kalau kita guna nombor terus. Let's say I want to find probability from 1 up to 2. Okay, in this case, both are included. But since this is continuous random variable, the probability would be the same if from 1 up to 2, but 2 is excluded. Or the other way around, from 1 up to 2, but 1 is excluded. Or between 1 up to 2, means both are excluded. All would be the same. Semua tu akan membawa probability yang sama because we finding the area. Kita integrate kawasan tu, so kita akan dapat probability yang sama. Okay, so let's do example. So given the function is 3 over 7 x squared from 1 up to 2 and 0 otherwise. So the notation here is fx. So we know that's the major hint that this is actually continuous random variable. So we have to show that the function is actually probability density function. So as before tadi kita ada highlight. In order to prove this, integrate all function must be equal to 1. But now since we only have one function here, so it's quite easy. You just have to directly integrate that function. So I integrate now from 1 up to 2. Our function is 3 over 7 x squared dx. So let's check the answer. 3 over 7 is a constant. I can bring it outside. Now we have x cubed over 3 from 1 up to 2. Simplify this up. We get 1 over 7 times with 2 cubed minus 1. So our answer is 1. So since the integration is equal to 1, we can conclude that fx is continuous random variable and fx is actually probability density function. Okay, catat. That's the step. Itu je kerja dia. Integrate function, buktikan mesti dapat 1. Okay, kebetulan soalan ni ada satu je function dan quite easy lah kita tinggal integrate satu function terus dapat 1. Kalau ada few function, then you have to integrate each function based on its range. Okay, now kita pergi part B. We have to find the probability when it's less than 3 over 2. Okay, so in order to find probability, remember just now it's basically the area. So for area, make sure you integrate based on the range. And in our questions, we only have one function from 1 up to 2, and our function is 3 over 7 x squared here. Means when it's less than 1, our function is 0. When it's greater than 2, our function is still 0. Because stated in the question, it's 0 otherwise. Maksudnya tempat lain semua kosong. Sebab tu saya tahu function dia kosong. Okay. Since we want to integrate for less than 3 over 2. So 3 over 2 would be here. 1.5 kan. So, in order to find probability, kita nak cari all this region. Okay. So, by right, actually, we will integrate, okay, for probability x less than 3 over 2 is from ini, kawasan pertama ni, negative infinity up to 1 and our function is 0 dx. Plus with, and then we continue. We want to find the orange region from 1 up to 3 over 2, 3 over 7 x squared dx. That's the whole function. But then for the first function, kalau awak tak tunjuk pun tak apa. Why? Because we know we have 0 as our function. Whenever we integrate 0, we still would get 0. Itu can be simplified as 0 straight away lah. Tak tunjuk pun tak apa sebenarnya. Saya sekadar tunjuk nak biar faham. Okay, actually we still integrate from negative infinity. But then since the function is 0, dia tak ada bawa apa-apa maksud. So the main key point here, kita nak tengok our integrate from 1 up to 3 over 2. And you choose the correct function. Which function given in the question? 3 over 7 x squared. Okay, so now process this function. 3 over 7 as before is a constant. Integrate x squared, you get x cubed over 3. And now it's from 1 up to 3 over 2. Simplify this up. So we have actually 3 over 2 cube minus 1 cube. So straight away compute this using your calculator. Here your final answer should be 19 over 56. Okay. Quite simple, very easy, quite straightforward. Just make sure you understand the concept of probability density function, which by the way, integrate the whole function must be equal to 1. Okay. And then in order to find probability, it's basically the area of the function. So you have to integrate to find the probability of that function. We proceed with next example. So next one, example 18. We have a continuous random variable. Okay. And it is actually a probability density function. But we have a problem now because we have a constant in our function because our function is ks cubed and it's valid from 0 up to 4. So from the first problem, we have to find value of k. Alright, so in order to find k, because it's already mentioned in the question, this is actually probability density function. So we know if I integrate the function, it must be equal to 1. For sure, it's 1. So using this concept, we can find k. So you just have to integrate the function based on the range. So from 0 up to 4, and our function is kx cubed. And this must be equal to 1. Okay. Now simplify this up. K can be factorized outside. Integrate x cubed. You get x to the power of 4 over 4. From 0 up to 4. Okay. And then straight away substitute the limit. So we have 4 to the power of 4 over 4 minus 0. So finally k is actually 1 over 64. Okay, so we already find value for k. So next part, we have to find probability. That's for question B, C, and D. Okay, so for that part, first, I once again sketch a number line so that you can clearly see the region. We only have function from 0 up to 4 just now. Okay, and our function is actually x cubed over 64. So when it's less than 0, function would be 0. When it's greater than 4, function would be still 0. Okay, so now we can find the probability. So, okay, part B, the question asks us to find probability from 1 up to 3. Okay, so based on our number line, 1 up to 3 lies in the same region, same function. So, straight away use the same function, you may start the integration process. It's from 1 up to 3 of x cubed over 64. Okay. So 1 over 64 is a constant you can factorize outside. Integrate x cubed, we get x to the power of 4 over 4. Okay. And then straight away substitute the limit. It's basically 3 to the power of 4 minus 1. Simplify this up. Here, our final answer should be 5 over 16. So that's for the part B, probability from 1 up to 3. Just a reminder, since this is actually a continuous random variable, so inequality sign doesn't matter. Means this is still the answer if we want to find probability from 1 up to 3, where 1 is excluded, of probability from 1 up to 3 where 3 is excluded, or when it's between 1 up to 3. So for all of these cases, we still have the same answer. Okay. So moving on, part C, we have to find probability when our x is greater than 2. So based on the region, now I'm using a blue color. So for 2, we would find from 2 up till positive infinity. So if I want to integrate, this is actually from 2 up to 4. I stop at 4 because that's the um, bounded region for x cubed over 64 dx. And then if we goes on from 4 up to positive infinity, our function is basically 0. And we know because the function is 0, so the region also will be 0. Okay. So now we just have to process the function. So this would be equal to 1 over 64 of integrate x cubed. We get once again x to the power of 4 over 4 from 2 up to 4. Simplify this up, we get 4 to the power of 4 minus 2 to the power of 4 times with 1 over 256. So here our final answer will be 15 over 16. Okay. And then last one, part D. We have to find probability when it's at least 4. Okay. So I just highlight the region when it's at least 4. We basically have to find, alright, the region that I highlight with yellow color. So based on our number line, this is actually region from 4 up to positive infinity, and our function is basically 0. And as before, since this is 0 function, our final answer also will be 0. Okay, settle for that part. So this is actually how you find probability for continuous random variable. Okay, so you just have to integrate the function based on the range, based on the region. Okay. Okay, next one. We still have a continuous random variable here. Our function is in the form of piecewise function. So our number line is quite tedious here. Careful with the range. So find the value of constant k. Okay. So this is basically following the same step as before. If we want to find the constant, remember integrate the whole function must be equal to 1. So since now we have two different functions here, we must integrate each function based on its region. So start with the first function from 0 up to 2. Our function is k times with x plus 1. Okay. plus with. Okay, careful here. Now, second region is from 2 up to 3 and our function is 2k. And this must be equal to 1. Kalau tak buat sama dengan 1, nanti hanging lah kan. Tak dapatlah jawapan k tu apa. So, dia mesti equal to 1. Okay. Now, carefully integrate 1 by 1. K is a constant. So, tak ada masalah. Bring it outside. Integrate x, we get x squared over 2. Integrate 1, we get x. Okay. And then for 2k, integrate 1, we get x. That's from 2 up to 3. And this is equal to 1. After that process 1 by 1, you just have to directly simplify. So if I substitute 2 there, we get 2 plus 2. So that is 4k. And then plus with 2k equal to 1. So finally, we know that k is actually 1 over 6. Okay, settle. Next one, we have to sketch the probability density function. Okay, so in order to sketch the function, let's rewrite back the piecewise function after we obtain the value k. So if I rewrite this back, this is actually for the first one is 1 over 6 times with x plus 1. That is from 0 up to 2. And then next one is 2k. So 2 over 6 is 1 over 3. That is from 2 up to 3. And we have 0 otherwise part. So based on this function now, we may start sketching the graph. So how do we do this? Okay, you just have to directly substitute the value of x into the function to find value of fx. So I just start with the x's first. So always label your sekejap, saya lukis semula. Always label your x's. So x-axis is x, y-axis here is name of our function, here is fx. So I use fx here. Next, just label value of your x. So we have 0, 2, and 3. Okay. Now, just substitute value of x into the function. For starter, so let's say first one, we have 0. So substitute 0 into the function there, we get 1 over 6. And it included because we have equal sign there. So for when it's 0, our fx is 1 over 6. So I just use that 1 over 6. Okay. Next, substitute 2 into the function. We get there 3 over 6. So it's half. And it's also included. Sorry, it's excluded. Saya salah salin tadi. Okay. It's excluded. So when it's 2, it's half. Excluded. So to connect between these 2 points, refer to the function. Now, our function is x. It's linear function. So just a straight line there. Okay. Next part, moving on to the second function. So when x is 2, our fx value is 1 over 3. So I just label 1 over 3 and it's included. So then circle. When x is 3, fx is still 1 over 3 and it's included. And it's a constant, so just connect between those 2 points. And that is the basically graph for probability density function. You just have to directly substitute each value of x into the function and then connect between the 2 points based on the function. Okay, settle. Moving on, next one, part C and D, we have to find the probability. Okay. So for part C, we have to find probability from 1.5 up till 2.5. Okay, so if we refer to the function, or you may use number line, 1.5 lies on the first function and 2.5 lies on the second function. So we would have to integrate 2 different functions here. Careful with the range. Okay, so first one, we may begin with 1.5, but then we have to stop at 2 because that's the bounded region for the first function of 1 over 6x plus 1. Okay. And then plus with the second function, continue, it's from 2 up to 2.5. And the function is 1 over 3. Okay, so this is the main key point here. Careful with this region. That's the main key point. That's the main marks. Okay, so kalau exam dia akan check ni. Awak arrange the limit correctly. Choose the correct limit with the correct function. So careful bahagian tu kena hati-hati. Okay, and now you just have to integrate as usual. So we get for first one x squared over 2 plus x. And then for the second one, it's just x. Okay. And then substitute the limit as usual. I skip that step, but awak kena show kalau masa exam tunjuk substitute limit one by one. Here you should get 19 over 48. Okay. Settle part C. And then last one, part D. D, we have to find probability when x is greater than 1.8. Okay, so for 1.8, it's in the first function. If it goes to positive infinity, so we have to use the second function. So maksudnya sekarang yang berbeza dia sikit je bahagian limit. So start with 1.8, still have to stop at 2 sebab tu kawasan untuk first function. Okay. And then for the second one, kita still samalah. From 2, stop at 3 because that's the bounded region for second function. Okay. And then same as before, integrate one by one. Make sure your limit is correct. Okay. After that, substitute the limit. And here your final answer should be 43 out of 100. Okay. Settle. So, it's still using the same concept of integration. Nak cari apa-apa, kena integrate. Tak ada cara lain. Okay. So, we proceed with last question for probability density function. Alright, so here we have a continuous random variable in the form of piecewise. From 0 up to 2, it's A. But from 2 up to 5, we have A times with absolute of x minus 3. Okay, for the first part, we have to show that A is actually 2 over 9. Okay, we have a problem here. Why? If we recap back for first topic, integration, you didn't learn on how to integrate absolute function. Kita ada modulus ni. Itu absolute function. So, kalau awak ingat semula, masa topik 1, kita tak ada belajar pun macam mana nak integrate absolute function. Kan? Tapi kita tak boleh ignore ada absolute sign there. Okay, so what do we have to do here is we have to define first the absolute value. Okay, kita kena buka dulu ikut range yang sebenar by using concept of basic definition. You already learned this from previous semester topic 2. Okay, so if we have A times with x minus 3, it's actually, apa tu sebenarnya? Dia akan jadi positive of A times with x minus 3. Bila dia positive? When our function is at least 0, means when it's at least 3. And then we would have negative function. Okay, so negative of A times with x minus 3 when our function is less than 0. So when x is actually less than 3. Okay, so if I have to rewrite back this function, saya menggunakan number line lah ya, biar nampak lagi senang. Okay, our function first one is from 0 up to 2. And then second one is from 2 up to 5. Okay, first part from 0 up to 2, we don't have any problem because our function is just A. Okay, itu tak ada masalah. Itu sekadar A je. But from 2 up to 5 just now, kita dah define based on basic definition of absolute equation. Kita ada dua function berbeza, berubah kat mana? Dekat 3. Itu region kita. So, kita ada tambah limit lah. At 3, kita kena berubah juga. Okay. So, When it's greater than 3, so maksudnya based on the number line from 3 up to 5, we will use a positive function, a times x minus 3. When it's less than 3, maksudnya kat sini from 2 up to 3, we have to use the negative function. Negative of a times with x minus 3. And then because it's 0 otherwise, maksudnya negative infinity up to 0 is 0. 5 to positive infinity pun 0. Itu function kita yang sebenar. Okay. So, if we have to show that a is actually 2 over 9, what the question asks for, means we have to integrate each function and then equal to 1. Kan? Itu syarat probability density. So, integrate semua function mesti samakan dengan 1. Okay. So, start with the first region. From negative infinity up to 0, function kita 0. So, confirm dapat jawapan 0. Saya tak tulis lah. Okay. Saya proceed kepada second function. That's from 0 up to 2 and our function is A. Settle. Proceed with the third function. From 2 up to 3, we use a negative function there. So, negative of A times with x minus 3 dx. And then pergi kepada fourth function. Next one, from 3 up to 5 of A times with x minus 3 dx. And then for the last function, 5 up to positive infinity, dia still function kosong kan? So, it's still 0 lah. Saya tak buat apa-apa kat situ. And this must be equal to 1. Mesti ada equal to 1. Kalau tak ada equal to 1, awak tak boleh settle value for A. Okay. So, now we have to integrate one by one. Careful kat situ. Okay, first one, integrate A, we get AX. Okay. Second one, x minus 3. So, we have x squared over 2 minus 3x. This is from 2 up to 3. And then for the third function, it's also the same, x squared over 2 minus 3x. But this is from 3 up to 5. Okay. Next, simplify one by one. So, we will get 2a. Okay. Minus with, if I substitute 3, we get negative 9 over 2. Substitute 2, we get negative 4 because it's minus. So, plus 4. Okay. Substitute 5, we get negative of 5 over 2. Substitute 3, we get negative 9 over 2. So, plus 9 over 2. Equal to 1. So, now we will get 2a. And then plus with 9 over 2. Sorry, plus with a over 2. And then plus with 2a equal to 1. So we will get 9 over 2, a equal to 1. So finally a should be equal to 2 over 9. And that is what the question asks for. Ya, dia panjang lah sebenarnya. Ni tapi dia tak ada calculation yang susah pun. Dia leceh je, tedious tapi calculation dia simple. Function dia pun function yang simple. Cuma tricky part dia just now sebab kita ada absolute function, ada modulus, kena define dulu. So range soalan akan berubah. Kat mana yang berubah? Kat bahagian 3 ni tadi. Before 3, kita kena guna negative function. After 3, kita kena guna positive function. Kalau yang tu awak tak dapat, awak takkan berjaya lah show that A is actually 2 over 9. Okay. Settle. Okay. Kita dah berjaya show. Next part, we have to find probability from 0 up to 3. Okay. So, if we check back, 0 lies on the first function. 3 lies on the second function. And then from 0 up to 3 tu, up to 3 kalau kita refer balik, okay, saya highlight lah kawasan yang kita nak tu. Saya highlight colour biru This is the region. Okay, so maksudnya kita kena buat apa? From 0 up to 2, kita kena integrate A, which by the way just now is 2 over 9. From 2 up to 3, kita kena ambil negative function yang ada, kita dah define siap-siap tu. Jangan tersalah ambil function lah, kalau salah jadi mengarut kat sini. Okay, so itu yang kita kena cari Alright, so saya tulis semula, it's probability 0 up to 3. 0 up to 3. So when it's 0 up to 2, it's A, so 2 over 9. plus with from 2 up to 3, kita kena ambil negative function. So, negative 2 over 9 of x minus 3. Okay. Ini je part yang kena hati-hati. Make sure correct limit with the correct function as before. So, now you may start integrate. First one we will get 2 over 9x. And then second one we will get 2 over 9 times with x squared over 2 minus 3x. Okay. Simplify this up. Substitute each limit. We get 4 over 9 for the first one. And then this is substitute 3. We get negative 9 over 2. Substitute 2, we get negative 4. So it's plus 4. So finally, our probability is 5 over 9. Okay. Settle part B. Next one, part C. We have to find probability absolute of x minus 3 less than 2. Okay, so now this is something else because we have a absolute equation, absolute inequality in our question. So we have to simplify it first to find what is the actual region. Kawasan mana yang kita nak kena cari sebenarnya. Okay, since this is less, we can open up. It's actually from negative 2 up to 2. And macam biasa, kalau kita jumpa soalan, x je yang bahagian tengah-tengah kan. Kita tak ada jumpa x minus 3. So, in order to get rid of negative 3, kita kena plus 3. So, kalau dah plus 3 kat tengah-tengah, kita kena adil dan sama seperti biasa. So, this is actually probability from 1 up to 5. Itu yang soalan nak sebenarnya. And if we check back the function based on its region from 1 up to 5, saya pergi kepada number line tadi. Ni. Kita cuba highlight colour lain lah, colour pink. From 1 up to 5, dia melangkau jauh ni. Okay, 1 tak ada, saya tambah. 1. Okay, daripada 1 ni up till 5. Kita ada pergi jauh. 3 different region kat situ. 1 up to 2, first region. 2 up to 3, second region. 3 up to 5, the third region. Okay, so hati-hati. Stopkan setiap limit tu. Jangan tersalah function, tersalah limit. Okay. So, kita pergi satu-satu. So, this is actually start with the first one tadi. From 1 up to 2. Okay, first function kita is 2 over 9. Tak ada masalah. Okay, pergi kepada second. From 2 pula. Bukan 1. From 2 up to 3. We choose the negative function. To negative 2 over 9x minus 3. And then last one from 3 up till 5. Positive function of 2 over 9 x minus 3. Dia jadi complicated sikit. Dia tak susah. Dia bukannya calculation yang susah, tapi dia leceh je lah sebab dia melibatkan 3 function yang berbeza. Hati-hati bahagian tu. Okay, so integrate one by one as usual. Okay, so first one we get 2 over 9x. This is from 1 up to 2 minus with 2 over 9 times with x squared over 2 minus 3x. That's for the second one from 2 up to 3. And then for last one, function still the same but now it's positive. So x squared over 2 minus 3x from 3 up till 5. Substitute the limit one by one as usual. Saya skip bahagian tu. Awak boleh kira. Masukkan satu-satu limit. Our answer here should be 7 over 9. Okay. Settle. Okay. So now, kita dah boleh pergi kepada last one. We have to find mode. Okay. So in order to find mode, based on the definition, mode is actually highest probability. Highest probability. Okay. So, in order to find the highest probability, basically you have to refer to the graph. Tak ada cara lain. Awak memang kena tengok graph awak macam mana. Okay. So, sekejap ya. Saya salin semula piecewise function kita ni. So, dah senang kita nak lukis graph. So, just now it's actually 2 over 9. When it's 0 up to 2. And then we have 2 over 9 times with our absolute of x minus 3 when it's 2 up till 5. And then it's 0 otherwise lah. Sebenarnya dia tak ada tulis, saya yang tambah. 0 otherwise. Tempat lain dia kosong. Okay. So now sketch the graph. Macam biasa, mesti ada paksi, x-axis, and then we have fx. Okay. So first one, when it's 0, our fx is 2/9. So kita bermula je lah dekat 2/9. Okay. Included. And then when it's 2, when x is 2, it's still 2/9 kan? Sebab dia tak ada apa-apa function. So saya kenakan je straight line there. Okay. So it's the first function. Kita pergi function yang kedua. If I substitute 2 into the modulus, kita still dapat 2/9 tapi sekarang dah included. So kita dah kena tukar status. Dia dah jadi dan circle. Okay. And then if I substitute 5 into the function, kita akan dapat apa tu? Kita akan dapat 4/9. Okay. And it's included juga. Okay. Alright. So between these two, from 2 up to 5, saya tak boleh terus sambungkan straight line macam ni. Yang kalau kita buat terus macam ni, dia akan jadi salah. Kenapa? Kita kena refer balik to the function. Function tadi ada modulus. Okay. If awak study balik, awak ingat balik apa yang awak belajar semester lepas, when it's absolute function, graf kita macam mana? Graf kita mesti bentuk V. Kan? Absolute. Okay, V. So, bila V ada X minus 3, our graph akan shift to the right side. Dia akan start pantul kat bahagian 3. So, same thing happen here. Maksudnya, if I have 2/9 times with X minus 3, dia akan ada pantul dekat X equal to 3. Itu dia. So, kat situ akan jadi shape. Saya salah colour. Sekejap. Hijau tadi. So, dia akan turun pergi 3. Sambung balik naik atas. Itu sebenarnya graf kita. A bit tricky for that part. Tapi semua benda ni awak dah pernah belajar. Okay, hati-hati nak sambungkan graph. In order to sketch the graph, refer to the function following the basic shape of that function. So kalau dia X, yes, linear straight line. Kalau tiba-tiba dia kuadratik, kenalah buat graf kuadratik. Kalau dia cubic, lukis graf cubic. Macam soalan ni, dia graf absolute function, absolute value. Graf kita bentuk V. So kenalah lukis bentuk V kat situ. Okay, itu kena hati-hati. Alright, now, because we actually want to find the mode. And as I said before, mode is basically highest probability. So, if I check the graph, kita kena tengok kat mana graph tu paling tinggi. The highest one. Highest is here. When our fx is 4/9, our x value is 5. So, mode straight away from the graph is actually 5. Itu je cara kita nak cari mode. Dia memang macam tak ada jalan kerja, tak ada kira-kira. Tapi actually, it's refer to the graph. Tengok daripada graph. Tengok graph paling tinggi ada kat mana. That's actually value of our mode. Okay, that's all for probability density function of continuous random variable.